All right, here we are with the new information for today, and we made a sketch on our paper. Each of us received a paper, and we held it long ways, and we drew 10 positions of a spring, as I did on the board. We labeled them 1 through 10, and now we're going to add some values to it, or labels, not values. So I want you to draw a dotted line that represents the equilibrium position. So how many should it go through, John, if I'm putting it through equilibrium? How many times does the spring reach equilibrium?
3 times.
3 times. All right, so you should aim for 3 boxes, and I want you to put that dotted line through, and somewhere, mine didn't fit on my paper, somewhere identify that line as the equilibrium position. That's where the mass hung freely before we pulled it down. So identify it as equilibrium. Can you fit it on there, Trent? The word equilibrium. And that's the dotted line. All right, now indicate that we are going to indicate that a force has been applied to this equilibrium position. So draw an arrow down from the very first position and call it a pull. So you know a pull is a force. So indicate that a pull has been added. And then the new position, this is at number 2, the new position is not called equilibrium anymore. What's this position called? Dimitri? What's that position called when it's the furthest away from the equilibrium?
I'm gonna try
Yeah, that position is called something. Amplitude, right.
Yeah.
Alright, so now in position 2, draw a line, and it's the furthest away from amplitude, from equilibrium as it's going to go, and that's called the amplitude. How many times do you see an amplitude again on this map? John, how many other times do you see an amplitude?
Was going above equilibrium count?
It's the furthest away that it will go from equilibrium.
How many other
Well,
times?
but furthest away.
Yeah,
only
where
one.
else does it happen?
Does it happen at 6?
Yeah, it happens at 6. Mine doesn't look like it's the same, but it's supposed to be. So at 6, also mark that this is amplitude. Remember, amplitude is when it's the furthest away from equilibrium. And John, is there another spot? 10. So draw in an amplitude there as well. Alright, so we have 3 amplitudes and 1 equilibrium so far. Well, we have equilibrium at 3 spots, but 1 line representing it. Alright, I promised you a force, velocity, acceleration map. So somewhere on the top, indicate force equals negative kx, and also force equals ma. Just because we are dealing with springs, F equals ma does not go away, it still applies. So F equals ma, an old friend, and our new friend, F equals negative kx, have those hanging around in the wings somewhere on your paper. Now we're going to evaluate each of these spots. We'll start slow, but then we'll get going pretty fast on them. So on the position number 2, I want to know what is happening to velocity, acceleration, and force. Notice on F equals ma, these are best friends forever. F and a always do the same. So if one is increasing, the other one. If one is decreasing, the other. If one is 0, the other is 0, and so forth. So F and a, whatever F and a do, then whatever F does, A does, and vice versa. So that'll help us quickly get these two, because they will match, F and A. All right, let's start with B. So underneath, if you have room underneath of the position 2, I want you to write what velocity is doing. So observe, when I pull it down, right at the moment, or the instant of release, what is velocity at the very instant of the release? Your eye could not catch it, but you're 0. So right at the instant of release, there's no velocity. So we put v equals 0 under position number 2. What is happening to force and in what direction? What's the name of the force that we are studying in spring systems? What kind of force is this? It starts with an R. It's the force that always... What? Recursion formulas are in math. But we are studying a force that always... It always wants to get back to equilibrium. Starts with an RE. R-E-S.
Restoring.
Restoring force. Okay. So I'm going to say, I'm going to put that up there. Force, restoring force. Restoring is the name of that force. F equals negative kx. Since you forgot, I put it on our map. So indicate the force is restoring. I'm going to emphasize that by putting a little r, a subscript. This is force restoring, restoring force. All right, so what is happening in force at that point? And it turns out, can you see from my acting, here's the extent of my acting career. You see, I can feel the force, see the shake in my old hand. The force is the greatest at amplitude because force is related to how far away it is, and at amplitude it is at its furthest point. So restoring force is at a max. And we'll put an arrow to show that restoring force is up, and it is at max. So I might ask you, why do we say restoring force is at a max at amplitude? And your answer is because x is the highest, and it will cause that force number to be the highest at a max. All right, now we took care of velocity, we took care of force, and now we do acceleration. And acceleration will always mimic what force is doing. So acceleration is also at a max. All right. Put those 3 in. You got them? All 3? All right, and also the direction of acceleration. So I'm asking you for the direction. I didn't give you a direction for velocity, but it's upward as well. It's at 0, so it's kind of hard to say what direction it is. But we know in a second instant it's going to be going upward. All right, have you got all that? I don't see it, Trent. I don't see it. All of this has to be under number 2. All right, because you will have to recreate this from your beautiful mind and be part of it.
This is literally the whole test.
So it should make sense. It's not something you memorize, it's something you understand. Velocity is upward, but the amount is 0. Restoring force is at a max because x is at a max. And the acceleration always mimics what force is doing. All right, so now we go up to 3. So tell me what you think, use a pencil, what velocity, restoring force, and acceleration are doing at snapshot number 3. Just try to write it down with pencil so you can erase.
No, I know what it is.
What is happening to velocity there? What's happening to restoring force? And what's happening to acceleration? All right. Obviously the thing is moving, so it has a velocity. Velocity was 0 here, so we can say that velocity is increasing in the upward direction. It can't go lower because it was at 0, so it's got to go upward. Restoring force at snapshot 3, well down here it was at a max, so it's not going to go any higher, so it must be decreasing, but in the upward direction. The restoring force is less at 3 than it is at 2 because x has gone down. The distance to equilibrium is less. And A will mimic force restoring. So it's going to do the same thing. So A is decreasing in the upward direction. Now, from an earlier physics principle, when velocity and acceleration in the same direction, is the object speeding up or slowing down? Do you recall that?
Say it again.
When, right here, velocity is upward and acceleration is upward. When they're both in the same direction, is it speeding up or slowing down? That was like a chapter 1 thing. Do you recall? But it is speeding up. So alongside of 3, I want you to say speeding up. Alright, so as it approaches, as it goes from amplitude toward equilibrium, it is speeding up. Alright, at 4, let's see if you can help me with this one. Alright, Trent, let's trace what velocity was doing here and here, and so what do you think it's doing at equilibrium?
So that doesn't mean you can't go any higher, right?
Well, it started at 0,
Yes.
and then it was increasing. So what do you think is happening at equilibrium?
It's just going higher.
It is. In fact, right there is going to be at a max. Alright, so velocity is at a max here. Velocity max, and it's still in the upward direction, so draw an arrow there. And what is happening to the restoring force? Dimitri? Force restoring, F sub r.
Oh.
If so far, we're at the amplitude, restoring force was at a max, and it's decreasing. What's going to happen to restoring force when it's right at equilibrium? It is, because it's done its job. It wanted to get the mass back to equilibrium. It did. It's in equilibrium, so it's happy. So restoring force is 0, and acceleration will mimic that as well. All right, so
Is there any direction? It's just
it's
equilibrium.
kind of hard. Restoring force, since it's where it should be, there really isn't a clear direction.
Horizontal.
Whenever it's 0, yeah. Alright, let's go on up. So, Kevin, help me with position 5. So, why did it not stop here? Because restoring force is happy. Why didn't it stop? Because it had a velocity. So it couldn't, there was nothing to stop that velocity. So it kept going past equilibrium. So, sort of a exercise in frustration. I want to be at equilibrium, so I'm far away from it. I let go, it goes up past it, it comes back, it passes it, it goes up and past it. It's just a nightmare. Alright, so where are we? Number 5. So Kevin, see if you can trace velocity and force restoring and acceleration at number 5.
So
Are you keeping them all straight?
Ah.
Alright, looks like you're doing it. Good job. Alright, are they fitting on your graph? Good. Alright, go ahead, Kevin.
Velocity is decreasing.
Right, well, it's at a max, so it can only go down.
Right.
And what this time, the velocity, as you're watching the thing, is still going up.
So it's decreasing in an upward direction.
So velocity is up, and it is decreasing. Alright, Kevin, force restoring.
Is going to be increasing.
Because it was at 0 a moment ago, so it's going to be increasing. But in what direction? Remember its goal.
Down.
Right, it went above equilibrium, so now it's going to try to pull it down, and acceleration. Kevin?
Same thing.
Alright, increasing, downward. Alright, so now we've got 5. Alright, so Drew, help me. It's going to go all the way up to amplitude again. What is going to happen to velocity at amplitude?
Velocity to 0.
Right, and why is that? Because
Because the spring is going back to the
Coconut
spring.
caramel.
Thing that it would be without the weight on it.
it is trying to get, well, it's actually going to coil past that. It's just that when it's at the top, it's gonna change direction. So one's going up, and then it's gonna go down. So just for an instant, it has to stop to change directions. Does that make sense?
Just zoom.
All right, V equals 3, Adam. V equals 0. Yeah. Kevin, you might have to really zoom in. To
Yeah,
that.
I zoom in a little bit. Eh.
Get the conversation.
You might want to put it.
Yes, it's just different.
Yeah.
That's clean.
So you hit 7 point whatever 36 E22.
Wait, does it go in more?
It's raw. It's raw footage.
Look at that.
Right.
Look at that man.
Well, it's just
You're
sound
going
out at that point.
All right.
Oh, we got a really big number.
Doesn't matter. What force is possible? I mean, you got a 365 kilogram thing going, so. All right, so velocity is 0. So who was giving me this?
Drew.
Drew. V equals 0. So what's going to happen to restoring
See, now I
force?
went max.
Downward direction.
All right, so force restoring is max. Because it's as far away from equilibrium as it's going to get, causing this to be big, and in the downward direction, and acceleration. All right, so it's going to mimic force restoring. All right, mine's getting kind of smushed up here. Hopefully you can read yours. All right, number 7. Let's walk me through that one, Jonathan. I'll put it way down here. So what's happening to velocity, John?
Increasing in the downward position.
Which way?
Down.
Right, it's moving downward, and would you say it's increasing or decreasing or 0 or at a max?
It is increasing.
What?
Is it increasing?
Yes, because we were at 0, so now it's increasing. What about restoring force?
Decreasing.
Decreasing because just the snapshot before it was at a max, so it's decreasing. And what direction is it?
Up.
Restoring force always wants
Well,
to
actually
get it
down,
to
because-
equilibrium. So it's above equilibrium, so the restoring force is downward, and then acceleration,
It's the same thing.
same thing as restoring force. All right, so here, I forgot to go back to snapshot number 5 and tell me, is this one speeding up or slowing down on number 5? I forgot to indicate that. Notice velocity is upward and acceleration is downward. Jordan, how will that work when they're opposites? On number 5, I forgot to put this in. Is it speeding up or slowing down?
It's slowing down.
Because velocity is one direction and acceleration is in the other. And so slowing down, put that alongside number 5. All right. So what about this one? Who is doing? John, is that one speeding up or slowing down, the one you just did?
Speeding up.
Pardon?
Speeding up. Everything's going down.
And because they're both in the downward direction, it is speeding up. So up here next to number 7, speeding up. Okay. How many more? 3? All right. Let's see if Jordan, you can do number 8. Equilibrium, it's a boring one. What happens to velocity?
It's at the max.
It's at a max, and
Force restoring is 0.
and where's velocity and what direction is velocity?
Going down.
It is. All right, and then restoring force.
0.
All right,
And acceleration mimics it is also 0.
all right. Boring one. Okay. All right, another more interest, number 9, Dimitri, to velocity, restoring force, and acceleration.
Velocity is decreasing.
Right, because it was just at a max, so it's not going to go any higher. So it's decreasing, and in which way is it traveling? It's going downward, right, because you can see it was going up, and now it's coming down. So the velocity is downward. What about restoring force? It was at 0. So what'd you say? Increasing, okay. Increasing, and in which direction will that be? All right, remember, it always wants to get it to the word restoring tells you it always wants to restore to equilibrium. So it's going to need to go upward, all right? And then acceleration, it's going to mimic that. So Dimitri, is it slowing or speeding up there? Because? All right, velocity and acceleration are in opposite directions, so this one is slowing down. All right, Trent, finish this exercise. Number 10. What is happening to velocity?
Our number 10 and number 2 are the same.
Is it? Number 2, velocity is 0, you're right. And force restoring is definitely upwards, and it was increasing, so now it's at a max. And acceleration will mimic that. All right, very good. We got it all on there. Nice work. Was a little bit tedious. So, I will ask you questions like, what is happening to velocity at equilibrium? So without this picture, you might memorize the results, but I think you can see the trends and understand it better. Notice, look at what we created here. Thank you. Notice what we've created here with our snapshots. If I put them all together, I get a sine or a cosine curve. And notice there's the amplitude. So it works just like it did in math class. So, hooray. All right, so with that training in mind, can you look away from the board and from the work and answer this question? See if you can. All right, Kevin, where is acceleration at a max?
Acceleration at, what's it called? Get the amplitude.
Right, very good. And how did you get to that? What was your thinking?
Just remembered.
You remembered. All right, acceleration mimics what?
Force.
The restoring force.
Restoring force.
So where is it the greatest?
At the
See my hand? It's
bottom.
shaking. At
Amplitude.
Okay.
You not even know the circle of ways.
He likes to do 4 on the back though, so.
Yeah, it's just that
No, it
it
doesn't.
just
It's
stops
starting the
and
same
just
block.
lets it go around.
Wait.
Oh, so it's
There's no outside force.
wait.
There's no outside
Got
force.
it.
So you have conservation laws applying. Right, so.
I'm not going to fix those
Okay.
grades.
Anytime during physics you can. Alright, so where is force restoring force a minimum? Jordan, where is restoring force a minimum?
Jordan.
Without looking.
Without
See if you
cheating.
can figure it out.
A minimum, like, including 0?
Yeah,
I mean, okay. Isn't it always at the equilibrium?
right, and why is that?
Because you said that. Because it's not increasing or decreasing.
Yeah, because it's done its
By
job. It's restored to equilibrium, so it's at a minimum. Alright, Dimitri, where is velocity at a max? At what? Equilibrium. Alright, and I think those are the kind of questions I'm going to ask you when this is not in front of you and when your map is not in front of you. So I'm hoping that you do not just memorize it, but you see the trends and understand why. So, alright, keep this after your day 5 notes, and I think we'll stop there. We did enough brain train for that, so we have about 2 or 3 minutes to chill.
You may turn this off.
Okay, alright, that's it. Adam, so you get your map and show it to me. Bye.